Welcome back, everyone. Let's talk about graphing functions, specifically vertical and horizontal shifting of the graphs of functions. You can see in the figure to my left, which is a figure in your ebook in section 2.5, illustrating what we mean by a vertical shift. So if you have a function f of x and you add a number c to the function values, that means you're adding a number to all the y values, which would move the graph upward. If instead you subtract a number c, where c is positive, then you're subtracting c from all the existing y values and your graph moves downward. In the example with the parabolas, you have y equals x squared, which is your blue graph here. This is your original from your catalog of graphs. And if we wish to graph y equals x squared plus 4 and then x squared minus 4, what I want you to notice is the vertex of y equals x squared is 0, 0. If I move that up 4 units, then the vertex of my graph y equals x squared plus 4 becomes 0, 4. And all the other points move up as well. So for example, this guy plotted is 1, 1. This guy is negative 1, 1. So on your new graph, moving up 1, or excuse me, up 4, you will have the points 1, 5, and negative 1, 5. Now similarly, if I graph y equals x squared minus 4, then I'm going to shift y equals x squared down 4 units, so the vertex is now 0, negative 4. And similarly, if I take the point 1, 1 and I shift down 4, and negative 1, 1 and shift down 4, I get the new points 1, negative 3, and negative 1.
Negative 3.
So keeping that in mind, let's take a look at a graph that I've drawn for you that is a line segment going through 0, 0 and the point 2, 1. We'll call this y equals f of x. If I wish to graph y equals f of x minus 1, notice it's f parenthesis x parenthesis. That's the original function. The minus 1's outside the parentheses. That means you are affecting the y coordinates. So if I shift the graph in red down 1, because I'm subtracting 1, the point 0, 0 would become the point 0.
Negative 1.
The point 2, 1 would become the point 2, 0. And I would draw the line segment accordingly. Okay, and I've circled these in color-coded boxes for you to keep up with the graphing. All right, similarly, if we graph y equals f of x plus 1, the plus 1's outside the parenthesis notation for the function, so you're adding to all the y's, then 0, 0 would become 0, 1, and 2, 1 would become 2, 2, and all the other points would follow suit. Okay, so that's vertical shifting. All right, now let's take a look at a related concept, which is horizontal shifting. The figure that you see before you is also from your ebook, section 2.5. And so let's talk about horizontal shifting. With horizontal shifting, it's sort of backwards from what you think. Now, we're letting the constant c in all of these scenarios be positive so that we don't mix things up too much. The point here, and this is an equal sign, by the way, the point here is to replace x in the function with either x minus a fixed constant or x plus a fixed constant. and see what happens. Okay? And what we find out looking at the picture with the parabolas, and your blue graph is y equals x squared, that if we replace x with x minus 4, the graph moves to the right 4 units. Whereas if we replace x, in this case with x plus 2, it's going to move left 2 units. Okay, now let's do an example together. If I have the same graph I gave you earlier, the line segment through 0, 0, and 2, 1, and I wish to graph f of x minus 1. Notice it's f parentheses, x minus 1 parentheses. That means x minus 1 is replacing x. And essentially, let me just show you. This is what you're saying. X minus 1 would equate to x equals 0 and move the point to the position where x is 1. So when you replace x with x minus a fixed constant, the graph moves to the right. So this new graph would be 1, 0, and the point 2, 1 would become the point 3, 1, and the graph moves right 1 unit. That's f of x minus 1. Similarly, f of x plus 1, what you're really saying, for example, is x plus 1 would equate to 0 now. So that initial point, the left endpoint, would move to the position -1, and the y would not change. So we would have the point -1, 0, and then this guy 2, 1 would move over
and become 1, 1.
And we draw the line segment. Okay? Now to finalize, let's do a problem that sort of captures both elements. The question says if the point P is on the graph of the function f, find the corresponding point on the graph of the given function. The point P is 0, 5. The function you wish to graph is y equals f of x plus 8 minus 3. So what I see before me is x plus 8 replaces x in f of x. That moves the graph
Left 8 units.
I complete that operation, and then I work my way inside out and subtract 3 from the entire function. It means I'm going to move down 3 units. Now, I didn't give you the graph, I just gave you a point on the graph. So let's track this. If we have a point 0, 5 in the coordinate plane, and I'll fudge a little bit here on the scaling.
If I move left 8 units, that's going to put me at the ordered pair -8, 5. If from there I move down 3 units, that would put me at the point -8, 2. So this would be the new point on the graph where you've made these translations.